Let's talk about Liquid 3013 divide an array into subarrays with minimal cost 2. So it gives us a integer array nums and integer k and also integer distance. So we want to divide this integer array into k disjointed continuous subarrays, such as that difference between the start index of the here we want to have the cost to be minimal. So what is the cost? Is the value of the first element. So we need the cost sum of the cost will be minimal. So but need to satisfy several conditions is that we need to divide into k subarrays and also need the second subarray and the start index and the k subarrays should less start index less equal to distance. So we know the first element will always be selected, right? So then that means we need to select k minus 1 so this question is divide let the nums array to divide into k arrays is actually trying to let us to select k minus 1 smallest item, right? And then also the first one. But for the k minus 1 smallest item number in this nums, it needed to satisfy this kind of sliding window condition. So that means in our distance sliding window, we need to select k minus 1 smallest item into it in our to select the sum, right? So the question is actually sliding window top k. So there is a question called a sliding window median, right? So for that one, we use two heap. Actually, but the heap to add an item that is log operation, but delete an item that is uh, uh, on operation, right? So what we do is there are two kind of approaches. Is one is we write our own heap, we rewrite lazy delete, so that for the delete will average it to be O log n operation. Another approach is we use tree set to substitute this kind of heap. And for this question, it's not asking median, but it's top k. So the things that we can have two priority queue, right? And one is max heap, and another is a min heap, right? So because we want to see the max top k, right? Top actually want to select the top k minus 1, right? Because the first nums 0 is always being selected. So we want to see in a window, dist window, select the sum of top k minus 1. So we instead like the median, right? So now we need to pass in a size, right? So we need to maintain the maximum heap size to be k minus 1. And also when we add, right? So we add to the max heap. Um, when we add an item, we have sliding window, right? That means that we first add to max heap, then move back to min heap. If the max heap size is smaller than our size, the k minus 1, then we pull back one from min heap to max heap. And this move in, move out, we pass in the sum variable, long sum variable, right? So that is, we have the long sum variable with the max heap that is our smallest, right? Because we are always getting a smallest, so that this is adding, right? When moving, delete. If it is in the min heap, right? Then it will not affect the size. That is the bigger one, right? So delete, just delete it. But if in the max heap, we need to, because the size changed, so that if the size is smaller than our K minus one, we need to add back one item to the max heap. So when add, right, we should also maintain our sum variable. After this analysis, we just write code for this, right? We use tree set to represent the max heap and min heap. For max heap equals new tree set. And here the things that we are going to have int a, b, right? So I'll say um, if nums a equals nums b, right? So we first compare its value that will if value equals, then we compare index. And then we need to have min heap, right? Min heap, we should have this kind of min heap order reversed. So we have long, right? Sum. We should have for every slide window, we need to maintain a sum. But for the sum, we always have the non-zero, right? So the non-zero is always being added, and we have result equals long. But we need to find the minimal result, max three values, value. So what we do is that I have int a equals nums dot length, right? So for we iterate because the nums I for this question, right? Because it is we need it is actually choosing the non-zero already been select. Then we have sliding window from index one, right? And the size of the sliding window is dist, right? Um, dist plus one, right? Um, because this index can be this index can be this index plus distance, right? So there are one more element, so the size is this plus one. So in this plus one, we select k minus one smallest item, right? And so this is will be one of our candidate, and we find a global minimum. That is our result. So what we do is that for int I equals one, I smaller than n, I plus plus, right? So we're going to have sum equals here. We in our add num, right? We return the sum, passing the sum, max heap, min heap, and we we need passing the size, right? Because we need to make sure the max size, max heap has size k minus one, so we need passing the size and k minus one, and because we need a calculate the sum, so we also need this nums variable, right? And also we need the original sum, right? So let's say if I is greater equal to this plus two, right? Why this is plus two? Because um we are signing window is from index one, right? Because index zero, this kind of number will always be selected, num zero, right? So in this case, we are going to have a sum equals remove number max heap min heap, and we need to maintain. When we remove, we also need to maintain the size, right? The size will be k minus one nums, and I minus dist minus one, and sum, right? So we'll say if I is greater equal to dist plus one I, that is our first candidate. So our result equals mass dot mean result sum, right? So we'll then return result. So we'll write two help function, um, add number and remove number. And now we are not asking the median, but we are getting the sum, right? So for the add number, we also pass in the sum and return the new sum, right? So what we do is private long add number. So we're going to have tree set, right? Integer max heap and tree set integer min heap and int size and int nums and int we add this index, right? And we pass the original sum, right? Long sum. So this will be our add function. So we are going to have a so now let's add to min heap first. Min heap add index and let's get this index equals min heap dot pour first, right? So what we say is that we add back this max heap, right? Max heap add this I. And we'll say, well, because this add to our max heap, so our max heap is the smallest, uh, smallest k minus minus one item or size items, right? So if we add to max heap, that means this kind of will be in this kind of slide window is chosen. So we are going to have some plus numbers I. So we'll say if max heap dot size is greater than size, right? Because it add an item, then we'll have int j equals max heap dot pull first. So in this case, we'll do two things: min heap add j and our sum should minus equals num j, right? In the end, we return sum. This is the add item, right? Add to our window. And also we need remove when private long remove number, right? Remove index. So we also need a tree set integer or max heap and tree set integer min heap. We need to make sure the max heap size is always kept in this kind of size. It's not like the median that is just we keep max heap size be equal to min heap or equals to min heap plus one. But now we need to make sure the max heap has size that is k minus one. So we pass in this kind of size variable and in nums and um, anything else. And also, when we remove its index, right? Index, and we need a long sum, original sum, right? Because the if the item be removed from the max heap, the sum will be updated as well. So let's say if max heap contains index, right? Then we're going to have max heap the remove index. So in this case, we are as long as it is removed from active or somewhere minus nums index, right? And uh, the things that here, if we remove the one item from max heap, because we always keeping the max heap with size. If we remove, that means that will be size minus one, right? So of course we will say if max heap dot size smaller than size, we are added, right? But apparently this because we maintain is keeping that to be size, right? So if we don't write that, it will be correct as well. So we need to add one item equals from min heap for first. Then we're going to have max heap add item, right? So our sum shouldn't add equal to nums, right? So if else, that means that this index is from our min heap. If it is from min heap, we just have min heap remove this index, then that's it, right? Return sum. So this will be our code. And the Python code will be very similar. Mm. So we also use sorted list, right? Sorted set. Um, the things that we can also use lazy delete, but it will have a lot of code. From sorted containers imports sorted list. So we have max heap equals sorted list. We're going to have a key equals lambda uh, x. So will be minus nums x, then minus x, right? That is index value first, then index mean equals. So just be positive. Then we're going to current sum, right? You'll have a current sum, and result, and let's have a right? Current sum equals nums 0 because the first item will always be select, right? Because for this question, we need to transfer the question is sliding window from index one, right? And select k minus one smallest item, and the result is float I in f, and this n is the length nums. So what we do is set for I in range 1 to n, right? So we're going to have current sum equals add num max heap min heap need to maintain the size k minus one, and we need because we need to calculate the current sum, right? So we need to pass in the array. Actually, we have array, right? So um, add num. What we need? We just need the index I and the current sum, right? Um, let's also parse in size k minus one. Okay. So we'll write um, if I is greater equal to this plus two, right? Um, current sum equals remove number also passing the size um, I minus this minus one, right? And then current sum. So we'll write if I is greater equal to this plus one, right? The result equals mean result current sum. In the end, return result. So we can define add a number. So we need to have a size, right? And index and current sum, right? So we're going to have mean heap dot add index and that have I equals mean heap pop zero, right? And max heap add I. So if max heap add something, we need to have our current sum should plus equal to nums I, right? Um, if we add something to max heap, so it is possible we need to check the size. If length max heap is already greater than size, then we need to rebalance the size, right? So we'll have g equals max heap dot pop zero. If we pop, right, we put that into min heap at G, and also because we pop an item, our current sum should minus equal to nums G, right? In the end, return current sum. So this is a add function, right? And also we need a remove function, remove number. So we also need a size index in current sum. So what we do is if we index in max heap, then what we do is max heap. We should remove this index, right? Because this is removed, our those kind of sum variable, current sum, right? Should also we maintain to manage the nums index. So mm, then what we do is max heap remove um, mm, because um, because removed, right? So we need to the size is now size minus one. Then we need to get one of the item from main heap. Um, so um, so we are going to have this is um, max heap add this kind of add, right? Because max heap add an item, so our current sum, of course, we should add nums add, right? So this is remove. Um, and it is the index in max heap, right? Else that index is in heap. So if it's in min heap, it's very easy. Just have min heap remove index, right? And in the end, return current sum. This will be our function. So did from containers import import sorted list. So we'll say the time complexity, right? Um, the time complexity will be because we use tree set, right? So there are every item will go to this kind of like a tree set or heap one time, right? That is a log operation for add and remove. So that will be n log k, right? Because we are making a k size heap. So that operation is log k operation. So that time complexity will n log k time complexity. And the space will be log k, right? Because there are always being k items in the heap. Do we create something else? If we create it should be just a log k, right? There is no some array related to the to n, right?